This is lesson 10-6, circles and arcs. This lesson is going to be a little bit longer. The video will be longer, and we're going to work on problems from it for 2 days. So we're going to start off just with what a circle is. A circle is a set of all points equidistant from a given point called the center. So a circle is a set of all points equidistant from a given point called the center. We have the diameter of a circle. The diameter is a segment that contains the center of a circle and has both endpoints on the circle. So the diameter is a segment that contains the center of the circle and it has both endpoints on the circle. So if you're looking at the picture right here, we have circle P, and P is the center, so we refer to this as circle P. The diameter is AB. It contains the center, and it has both endpoints on the circle. A and B are the endpoints, and they're on the circle, and it goes through the center. So that's a diameter. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. So a segment that has one endpoint at the center and the other endpoint on the circle. So the radius is half of the diameter. So if you look here, PC is a radius. It has a segment, and one endpoint's the center and the other endpoint's on the circle. PB is also a radius, or PA is also a radius. And all the radiuses in a circle are congruent to each other. They have the same length. Congruent circles have congruent radii. Okay, radii is just a plural for radius. So if two circles are congruent, that means their radiuses have the same measure. And then this is probably a new term, central angle. A central angle is an angle whose vertex is the center of the circle. So central angle is an angle whose vertex is the center of the circle. So in our circle P right here, angle APC is a central angle. APC, this angle right here is called a central angle because the vertex is the center of the circle. Okay, angle BPC would also be a central angle because it has the vertex in the center of the circle. Okay, we have a semicircle, which is half the circle. We have minor arcs, are smaller than a semicircle. And then we have major arcs, which are larger than a semicircle. Okay, so a semicircle is half the circle, like this right here, from A all the way to B would be a semicircle. A minor arc is smaller than a semicircle, like right here, arc BC, that's smaller than a semicircle. And a major arc would be larger than a semicircle. So if I was starting at A and I went through B all the way to C. But let's look at the picture that we have here and we'll go through the terms again. So STR, see how I have this arc mark? It's not a straight line, it's like a little curved. So arc STR, so I start at S, I go through T, and I go all the way to R. So the blue arc right here, that's a major arc because it's bigger than a semicircle. And arc RS in red is a minor arc because it's smaller than a semicircle. So let's name some arcs in the picture that I have here. So I want to know the minor arcs of circle O. See how O is the center? So that's how I refer to the circle as circle O. The minor arcs are smaller than a semicircle. So see if you can list any. I need at least two letters for an arc. Okay, sometimes I use 3 letters. And just like a line, you know, I'm naming the sort of endpoints of the arc, and I put a little arc symbol over it. So the minor arcs, like I could have AD, AC, CE, DE, anything that's less than a semicircle is a minor arc. Okay, so AD, CE, AC, and DE are all minor arcs. The semicircles are half a circle. And as we can see, DC and AE are diameters because they go through the center. So then you know that that's the semicircle. So to do the semicircle, I would use 3 letters, A, C, E, so I know which direction. Because if I just said AE, I wouldn't know if I'm going this way, talking about that semicircle, or this way, so I use the 3 letters. So arc ACE goes this way. CED starts at C, goes through E, and goes all the way to D. EDA starts at E, goes through D to A. Or DAC starts at DAC. It's also a semicircle. And then the major arcs that contain point A, so it has to be bigger than a semicircle, but yet it contains point A. So say I had DAE, okay, or ACD. So I start at A, go all the way through C to D, then I'm talking about almost this whole part of the circle, ACD, CEA, EDC, and DAE. Those are all major arcs. Now I can actually figure out the measure of an arc. The measure of a minor arc is equal to the measure of its corresponding central angle. Okay, so the measure of a minor arc is equal to the measure of its corresponding central angle. So that's easy to remember. The measure of an arc is equal to the measure of its corresponding central angle. So if I have this central angle right here, angle RST, and it's a central angle because the vertex is in the center and it's 50 degrees, then arc RT, guess what that is? Same thing, 50 degrees. So the measure of RST equals 50. So therefore arc RT equals angle RST, and it equals 50. So the measure of a minor arc, so this arc RT, measured in degrees, is equal to the measure of the central angle. And once I know what RT is, now I know what TQR is. TQR is this major arc. Remember, a full circle is 360, and I know RT is 50, so all I have to do is 360 minus 50, and now I know that arc TQR is 310. Okay, we got one more page of notes. The next thing we're going to talk about are adjacent angles. Adjacent arcs. Adjacent arcs, remember we've used that term adjacent before. Arcs of the same circle that have exactly one point in common. So adjacent arcs are arcs of the same circle that have exactly one point in common. So they're going to be arcs that are right next to each other. Arcs of the same circle that have exactly one point in common. Like if I'm talking about arc BC and arc CD, they're adjacent. They have point C in common. And arc addition postulate means the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. Okay, so if I know arc AB and I know arc BC, I can just add them together to know arc ABC. So it's the measure of the arc formed by two adjacent arcs is the sum of the measure of the two arcs. So the measure of arc ABC equals the measure of arc AB plus the measure of arc BC. And I use that M for measure. And I'm just using the letters for the arcs, and I use that little arc symbol above the letters. So the measure of arc ABC equals the measure of arc AB plus the measure of arc BC. So let's look at the example right here. What is the measure of each arc in circle O? So O is the center, so I'm calling it circle O. I want to know what arc BC is. Well, remember the arc equals the central angle. So if the central angle is 32, then arc BC is going to be 32. Then I want to know arc BD. Well, BD is BC plus CD. So 32 plus 58 is going to be 90. And then arc ABC. Well, I can see ABC. Since AC is a diameter, then I'm talking about a semicircle there. So arc ABC equals 180. And the last one I want to know arc AB. Well, if ABC is 180 and BC is 32, I just have to do 180 minus 32 and I will know what arc AB is. So 180 minus 32 is 148. Okay, so I can find out different measures of different arcs in the circle. Next thing I have is circumference. Circumference of the circle, remember, is the distance around the circle. It equals pi times the diameter. So the circumference is the distance around a circle, and it equals pi times the diameter. Or we use the formula circumference equals pi times diameter, or sometimes we use 2 pi r, because remember a radius is just half of a diameter. So either of these two formulas work. So circumference is pi times diameter, or circumference is 2 pi r. So depending on what information they give you. The next term is concentric circles, circles that have the same center. Okay, so I have two circles. I have like a circle within a circle, and they share the same center. That's called concentric circles. An important thing to remember, all circles are similar because there is a similarity transformation, such as a translation and dilation, that maps one circle onto another circle. Okay, so all circles are similar. What I did is I translated this, I moved it over, and I dilated it. So these two circles are similar to each other. The radiuses are different, okay, but they're similar to each other. So let's try a problem. I have a 2-foot wide circular track for a camera dolly is set up for a movie scene. The two radiuses of the track form concentric circles. The radius of the inner circle is 8 feet. How much further does a wheel on the outer radii travel than a wheel on the inner radii of the track in one turn? Okay, so I have a 2-foot wide circular track for a camera dolly. So you have this inner, these are concentric circles. I have this inner circle has a radius of 8, okay, and then the circular track for the camera dolly is 2 feet more than that. So the circumference of the inner circle is going to be 16 pi, because the circumference of a circle is 2 pi r, and the radius is 8, so that's 16 pi. The circumference of the outer circle is going to be 20 pi, because remember I have the 2-foot wide circular track, so if the radius of the inner circle is 8, then the radius of the outer circle is 10, and circumference is 2 pi r. Okay, so how much further does a wheel on the outer radii travel than a wheel on the inner radii of the track in one turn? 20 pi minus 16 pi. So the circumference of the outer circle minus the circumference of the inner circle. Now the measure of an arc is in degrees. When we were talking about the arc equals the central angle, that was in degrees. While the arc length is a fraction of the circumference. So if I actually want to find the length of an arc, I take the measure of the arc, which is in degrees, over 360, because a circle is 360 degrees, and I times that by the circumference of the circle. So basically I'm finding what part of the circle that arc is, and I'm timesing it by the circumference. So the measure of the arc over 360 times the circumference of the circle will give me the arc length. So if I want to find the length of arc AB, I'm going to find the measure of arc AB over 360, because that's the fractional part it is, times 2 pi r. So the measure of arc AB over 360, because that's a full circle, so I'm really finding out what part of the circle that arc is, and then I'm timesing that by the circumference. So if I want to find the length of arc XY in my example right here, finding the length of arc XY, and I want to leave my answer in terms of pi. So the length of arc XY, I use my formula. My formula says it's the measure of XY over 360 times the circumference, which could be 2 pi r or pi times diameter, depending on what you have. Okay, so I know that the measure of this arc is 90 degrees because the central angle is 90 degrees. Okay, so I have 90 over 360 times pi, and my diameter is 16. And then I just simplify that. I can do that in my calculator, and I get 4 pi. So that's the length of the arc. So I have the degrees of the arc, and I can also now do the length of the arc. Okay, and we're going to practice all that over the next 2 days.